This is a reminder Class Connect sessions are recorded and distributed for learning purposes listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. So we are on hold on guys, one second. We are on day 22 of quarter number 3. All right. Sorry guys, hold on one second. I'm going to go. Okay, so sorry about that. Good. So we are on day 22 out of 45 for quarter number 3, everyone. Oh my gosh, it is going by so fast. Tomorrow we are officially at the Monday we're officially over the halfway point. So today we are working on the midterm exam. You'll notice that that was switched from yesterday because I had some meetings to go to yesterday, so we had to move our classes. So today though we are working on the exam. All right. So for next week, I do want to let you guys know that there are no live classes for my class next week. All right. So the reason for that is because Monday, Thursday, and Friday I am out of the office for family reasons. All right, so I won't be here Monday, Thursday, Friday, and then on Tuesday and Wednesday, every single one of your teachers is actually out for teacher meetings. So there's actually no live classes at all for any classes on Tuesday, Wednesday. Smiley faces if that makes sense. So you do still have classes next week, Monday, Thursday, Friday, for all your other classes. Just know that for my class in particular, we won't have live sessions. Okay. That being said, you are still responsible for the assignments. There will still be assignments due because we still have school, but you'll just have recordings uploaded for those, okay? But the nice thing is there's no attendance tickets next week, so we don't have to worry about those. Okay, looking good. I'm getting lots of smiley faces for that. Is there any confusion about that? Next week you will be going over a couple quizzes, work and power, simple machines. You will have a really simple lab. It's called the Levers lab. I would actually say it's about as easy as the lab we just did, so it's definitely an easy one. And then Thursday you'll have a Unit 6 review. It's usually our game day, but instead everybody will just do what I usually call the alternative assignment. Still super easy. And then Friday will be about the properties of waves. I know I'll miss you guys too. I would much rather be with you than be in meetings, to be honest. But so sorry for me in particular. Okay, so for me in particular, next week I won't be in for Monday, Thursday, and Friday. But all of your teachers won't be in on Tuesday and Wednesday. Okay? One more time, thumbs up if that makes sense. Okay, so you actually have no classes for any class on Tuesday, Wednesday. You still do have assignments. All right, you still have things to do, but there won't be any actual live classes on Tuesday, Thursday. Or Tuesday, Wednesday. Cool. All right, let's go ahead and keep on going here. So today's objective, we are going over every single unit that we have done so far. So matter and energy, scientific method, Newton's laws, acceleration, force, mass, friction, gravity, fluid forces, density, buoyancy, and energy. We are going over all of those because today is our midterm exam. So make sure you have your midterm exam open. Link is in the chat box. All right, so make sure you've got that open. The midterm exam will officially be the largest grade in your class at this point. It will be 15% of your grade, so you definitely want to make sure you get it done. Make sure you get it done right away today. I will be entering zeros at 4 o'clock, which means that you can still complete it after that, but if you see your grade drop, it means you haven't gotten it done. You can still complete it. You'll still get full credit. It's just so that you have an accurate reflection of your grade. Okay? Now today what we're going to do is I'm going to go over the information you need to answer each question, and then I'm going to give you 30 seconds per question to answer. They're all multiple choice, so you probably won't need that much time. But if you're a slow test taker, or if you want a little bit more time to process, or if you're having trouble with having your assignment open at the same time, that's fine. Just take a picture of the answers. Take a picture of the slides, and then give me a green check. So you're going to do one of two things: either answer very quickly and give me a green check, or take a picture and give me a green check, just so I know everybody has either answered it or has at least the ability to answer it after class is over. Smiley faces if that makes sense. Smiley faces if that makes sense. Excellent, looking good. Okay, cool. So that being said, I will be turning off the chat during our time together just because I don't want anyone to accidentally answer a question in the chat box, right? Because this is an individual exam, not a group exam, as fun as that would be. So I will be turning off the chat, but you can still send me questions that'll just go to a private chat directly to me instead of to your classmates. So absolutely don't feel embarrassed. Absolutely ask questions. Plus, the thing is, no one else can see your question. So if you feel like it's a dumb question, I'm the only one that sees it and I'm not going to judge you for it, okay? So definitely send me questions if you need it, okay? Now here's the thing. I am going over the majority of the exam in class. I'm going over all the hard questions with you. There are a few easy questions though that would kind of just take up too much time to go over. So I have a video at the end of class. It's super short and that'll go over the easy questions with you. Okay, so we're going to do all the hard ones, then the easy ones will just be a video. But that being said, we are going to be jumping through many different questions, so just be aware that you're gonna be all over the place today, okay? So be ready to go. No worries, Alyssa, just go ahead and open up your exam. Cool. All right, everyone, let's get started. So first question we're going to start with is question number 2. Again, we're skipping around. We're starting with the hard ones. Easy ones will be in a video at the end of class. But the first, this question number 2 asks about matter existing in different states or phases can change when you add or take away energy. So for example, in order to boil water, we need to make the molecules go faster. So we need to add energy. In order to freeze water, we want those molecules to go slower, so we need to take away or remove energy, right? So we can see the hotter and hotter that you get, the more energy you have. The colder and colder you get, the less energy you have. All right, so this should be question number 2. This should help you answer question number 2, which asks, phase change occurs in which of the following? All right, so I gave you examples of phase changes. You have 30 seconds. Give me a green check when you have number 2 saved. You can also take a picture, but be quick. All right, waiting on a few more green checks. Alyssa, Amanda, Amir, Andrea, Tony, Bradley, Dorian, Dree, Dylan, Hope, Jackie, thank you, Jackie, Justin, thank you, Martina, Matt, Misael, Nate, Blossom, Yusra, green checks. I'm going to be pretty quick today, so we got to make sure we're on top of it. If you miss it, it's going to be in the recording, though, as always. Awesome. All right, so the next question we're going to go to is question number 5. So skip a few of them, go down to question number 5, which talks about the scientific method. Okay, so the scientific method, remember, is the basic pattern that we follow to solve problems. So the first thing that we do is we identify a question that we have about the world around us, and then we make observations about that to figure out maybe what's going on with that, right? So we have a question, we make some observations. From there, we make a hypothesis, which is going to be a testable, possible answer to the question that we have. That allows us to design and conduct an experiment that's going to give us some data. And from that data, we can compare our results to the hypothesis, figure out if we supported or disproved our hypothesis, and go from there, start over if we need to, or be able to continue doing that and showing the scientific world what that looks like. Okay, so this answers question number 5, which is when you use the scientific method to solve a problem, which procedure do you follow? Please go ahead and answer number 5. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. All right, need a few more green checks. Amir, Tony, Dree, Dylan, Ireland, Israel, Mel, Michaela, Miguel, Misael, Nate, Parker, Blossom, Stacy, Taylor, Yolese, Yusra. Green checks. 5 seconds. Then we're moving on. Again, if you miss it, it'll be in the recording. 3, 2, 1. Awesome. All right. I just realized you can't hear me, but I do see a bunch of green checks. So let's go ahead and keep on moving here. I'm so sorry. I realized I was muted. Cool. All right. So now we're going to skip over to question number 10. So question number 10 talks about one of Newton's laws, the first law, which is that an object in motion will stay in motion, right, maintaining constant velocity, which means both speed and direction, unless acted on by another force. The opposite is also true. An object at rest will stay at rest until there's an outside force, which means that objects, unless there's an outside force, they never start, they never stop, they never slow down, they never speed up, they never change direction. They will keep on doing what they're doing forever unless there is an outside force. Okay, so question number 10 asks, a bowling ball that is standing still on a table, what is it going to do? Please go ahead, use what we just learned, just reviewed, take 30 seconds and answer number 10. Go, go, go. All right, green checks. Remember, if you're feeling a little bit rushed, don't feel rushed, just take a picture and then you can go back to it later if you need to. Awesome, waiting on Amir, Ashton, Dorian, Dree, Dylan, Isaiah, Ethan, Hope, Jackie, Martina, Michaela, Misael, Parker, Blossom, Razi, Stacy, and Yusra. Green checks for number 10. 5 more seconds. 3, 2, 1. Let's go. All right, so now Newton's second law of motion, this one is actually related to both questions 11 and 12. So I'm going to give you a little bit longer after this is done to answer both of those questions. So remember that acceleration of an object depends both on the force that you apply to that object as well as its mass, right? So the bigger force you add, the bigger mass it has, it's going to change how easy it is to accelerate that object, right? So for example, the more mass something has, you need to apply incredibly much more force in order to get it to accelerate, right? Think about a refrigerator versus something really light like, I don't know, an empty cardboard box, right? So a filled box that's filled with a refrigerator versus one that's empty. The filled one is going to require much more force, okay? Now, Newton's second law of motion is an equation, right? So it says that the force applied to an object equals its mass times its acceleration. So force equals mass times acceleration. Force we measure in newtons, mass we measure in kilograms, and acceleration we measure in meters per second. All right, so question number 11 asks about, according to Newton's second law of motion, what does an object with more mass require? That's going to help us right here. And then question number 12 says, what does force equal, which we just talked about over here on this side. Please answer both of those. I'm going to go ahead and give you 45 seconds. Give me a green check when you have number 11 and 12 saved. Dylan, Ireland, thank you. Miguel, Michaela, Nate, Parker, Blossom. Green checks. Let me know that you're ready. 5 seconds. 3, 2, 1, moving on. All right, so now we're going to skip over to question number 14. Again, we are skipping around. We are skipping some of the easy ones that will be in a video at the end of class. All right, so let's go ahead. We're going to talk about the definition of a vector. So remember, vectors describe two things. Vectors are arrows that we use in physics, and the amount or the magnitude is represented by how big the arrow is, right? So magnitude is the amount of it, right, or the size of the arrow, and then obviously vectors also have a direction, which in this case is where the arrow points, right? The way the arrow points shows you direction. So two examples of vectors are velocity, which has both speed, which is the amount, and direction, which is the direction, and force, which has an amount of force, right? That's our magnitude, as well as the direction of the force or where that force is going. So both of those are examples of vectors. Question number 14 asks for the best definition of vectors. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Looking good. Amir, Tony, and Dylan. Green checks, please. Hope, Jackie, Michaela, Miguel, Misael, Blossom. Just want to make sure everyone's on top of this. 5 seconds. And here we go. All right, so we're now skipping over to question number 18, which talks about free fall. So remember that objects in free fall, if they're only influenced by the force of gravity, then they will all accelerate at the exact same amount, which is the acceleration due to gravity, 9.8 meters per second squared, which means if you drop them from the same place, they're going to accelerate exactly the same and hit the ground at the same time. Doesn't even matter what their mass is, right? A 1,000 kilogram mass is going to hit at the same time as a 1 kilogram mass. And again, this is if there's only gravity. So for example, we saw the bowling ball and the feathers in a vacuum drop. And even though one is really light and one is really heavy, if they had only gravity, they actually hit the ground at the same time. However, we don't always see that in real life. Just remember, for example, in real life, feathers don't fall at the same rate because sometimes air resistance is working against them, right? So if air resistance works against an object, it will slow them down. But in general, objects in free fall ball will hit the ground at the same time. So this is question number 18. 300 gram and 100 gram ball are dropped from a tower. Both are the same size and there's no air resistance. Which one hits the ground first? All right, give me a green check when you have number 18 saved. You have 30 seconds. Go. Yes, exactly, Andrea. So if there is no air resistance, that means they only have gravity, so they're all accelerating the same, right? Awesome. Good question. All right, looking good. All right, so give you a few more seconds. Alyssa, Amir, Dorian, Dree, Dylan, green checks, please. Justin, Mel, Misael, thank you. Nate, Parker, Blossom. 3, 2, 1, moving on. All right, so we're going straight to number 19, so we're going in order right here. So this talks about static versus kinetic friction. Now remember, the word static looks a lot like the word stay. So static friction is the friction that actually keeps objects in their place. It prevents an object at rest from moving from its place of rest. So it's the force between two objects that are not moving. It's the resistance force, all right? So before you can begin moving, you actually have to be able to overcome static friction, because static friction stops you. It keeps you in place. Now, once you do overcome it and you begin moving, at that point, it then becomes kinetic friction, right? Remember, the word kinetic actually means motion. So this is the resistance force against the motion of an object that's already moving. So you can see this over here. If the object isn't moving, it's static friction. If it is moving, then kinetic friction is trying to oppose it, and it's oppose its motion, right? All right, so the question number 19 is asking, when you push a box across the floor, what does the box experience? You have 30 seconds. Green checks when you have number 19 saved. All right, need a few more green checks for number 19. Amir, Andrea, Hope, thank you. Justin, Misael, Nate, Parker, Blossom. Welcome to the class, Andres. I have the link to the exam in the chat box for you. Don't worry about the attendance ticket. We're not doing that until the end of class. So just open up your exam and have that ready to go. All right, everyone. So we're skipping question 20, going to questions number 21 and 23. All right, so both of these two questions are about pressure. So remember, there are many ways to affect the pressure or the collisions of gases within a container, right? Remember, imagine each molecule is like a person in a very crowded room, and you can figure out how those pressure relationships work. So for example, if you increase the amount of molecules, just like if you increase the amount of people in a room, that's going to increase the number of collisions. You're going to run into people much more. And so therefore, pressure also increases. Remember, pressure and collisions are the same thing, the way that we talk about them, all right? So more collisions, more pressure. All right, so that should help us figure out one of our questions. Now, one of the questions also asks about temperature. So remember that as you increase the temperature of a gas, again, the increased temperature is actually going to make those molecules move faster and faster. So just like people in a crowded room, if people in a crowded room start moving faster and faster and sprinting around, they're going to run into each other more. So they're going to have more collisions and therefore more pressure. All right, so increasing the amount of molecules leads to more pressure. Increasing the temperature leads to more pressure. The only unique one that we talked about was volume, right? Which volume is unique because as you increase volume, you actually give the molecules more space to move around. And so therefore, they end up with less collisions and less pressure. So remember, that one was a kind of a special one. All right, so question number 21 asks about if the amount of gas in a sealed container increases, what happens to the pressure? Right, we talked about that right here. And question number 23 is asking about if you heat a container filled with gas, what will happen? We talked about that right here. You guys have 45 seconds. Give me a green check when you have both number 21 and 23 saved. Go, go, go. All right, waiting on a few more green checks. Amir, Andrea, Andres, Ashton, Dylan, Israel, Justin, Misael, Nate, Parker. Green checks if we have number 21 and 23 saved. Again, if you're having any trouble answering them in the time that I'm giving you, you can absolutely take a picture and then give me a green check. That way I know you at least have it saved for later. Edwin, we're currently working on the exam, so please make sure you open that up. Don't worry about the attendance ticket. We're going to do that at the end of class. All right, looking good. So obviously we just did 21 and 23, so we're going to go back to number 22, which was sandwiched in between them, but it wasn't related to either of them. So now we're going to go back to question number 2. So question number 22 asked about buoyancy. Now buoyancy depends on two things. the density of the object in that liquid, and then the density of the liquid or of the fluid, right? So remember, we talked about this a whole bunch, that if the density of an object is less than the density of water, it will actually float. Remember, density is the amount of mass per for the amount of space that it takes up, right? So mass per volume, right? So if the amount of mass in that object is less than there would be of water, then obviously it'll float, because for the amount of water that it takes up, it's much lighter. Same thing with the opposite, right? More density for an object means it sinks, and if it has the same density, it actually just stays suspended in the center of the liquid. Pretty cool to look at. All right, this is question number 22. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. All right, looking good. Waiting on Amir, Andres, Ashton, Dree, Dylan, Edwin, Jackie, Mel, Misael, Nate, Parker, Blossom. Green checks, please. While we're waiting for those green checks, really quickly, I just opened up the main chat again. Tell me, how are we feeling about this so far? Are we feeling good about this? Give me smileys. Let me know if you're feeling like you're confident. It's pretty easy. Not too bad. Let me know in the chat. Okay, good. Getting some thumbs up, some smileys. Awesome. See a couple people typing. Good. Just want to make sure I want to get your feedback just so I know that what I'm doing is actually useful, right? Awesome. Okay, good. All right, I'm going to turn the chat back off, but thank you. Yeah, Stacy, it always goes up around 2 o'clock, unless something crazy happens with YouTube, but I'll try to do my best to get it up by 2. Cool. Yeah, I know. Don't be stressed. All right, we're working on it together. We're going to do great together. Cool. All right, turning the chat back off, but let's go ahead and keep on moving. All right, so question number 24. So we're skipping back down. So question number 24 asks about Pascal's principle. So remember, Pascal's principle says that the pressure in a confined fluid, so that's a fluid in a container, will be uniform throughout the fluid in that container, right? Which means, which makes sense, right? So in a water bottle, if we have a liquid in there, the pressure at every point, top, bottom, side, okay, all of that pressure is going to be the same no matter where you are. Now, because of this makes sense that if you try to increase pressure at a single point in that water bottle, like you squeeze it in the middle, the entire water bottle also experiences that increase in pressure, which makes sense to us because we know that when we squeeze the middle of a water bottle, the top and the bottom also get harder from that extra pressure. Okay, so increasing at any point will actually result in an equal increase at all points. And you can see that here. These arrows get bigger the same amount at all points in the water bottle. All right, so this is number 24, which asks about when pressure is applied to an enclosed fluid, the pressure is. Go ahead and answer that question. You have 30 seconds. Ready, set, go. Green checks when you have it answered or a picture. Right, looking good. Give you a few more moments. Green checks. Thank you, Alyssa, Amanda, Amir, Andres, Dorian, Dree, Dylan, Edwin, Jackie, Nate, Parker. Green checks if we're good on number 24. Don't want anyone to feel like I'm leaving them behind. Awesome, thank you. Let's keep on going. All right, so Bernoulli's principle. This is actually the very next question, question number 25. So Bernoulli's principle talks about how airplanes can fly. Now remember that the shape of a wing is curved over the top, right? And so what happens is that air has to actually travel faster over the top of the wing to make it to the other side compared to the bottom of the wing, right? And as you travel faster and faster, your molecules spread out. And as those molecules spread out, that actually decreases the pressure. So we end up with a lot of pressure underneath from the slow molecules and very low pressure on the top from the fast molecules. And so what overall happens is you can see tiny little pressure pushing down, big pressure pushing up, and so overall you end up with a net force that goes up, right? The bottom part wins, the bottom forces win. And so this is what's called lift. It's an upward push that causes the plane to actually go up. All right, so question number 25 asks about air pressure on the top of the plane's wing decreases, and it asks about when is it going to decrease. Okay, go ahead and answer question number 25. You have 30 seconds. Go. All right, I know that's kind of a tough one, so I put a couple notes on the board. Give me a green check when you finish answering that one. Amir, Andrea, Andres, Ashton, Dorian, Dree, Dylan, Edwin, Ireland. Sorry, I know you just got back in, so let me know if you need anything. Matt, Michaela, Misael, Nate, Parker, Razi, Yolese, green checks for number 25. Again, over the top of the wing, those molecules are moving much faster, resulting in lower pressure. At the bottom, the molecules are moving much slower, resulting in higher pressure, right? So we know these two things are related. The speed of the air is related to the pressure of the air. Looking good. 5 more seconds, and then we're moving on. Again, if you feel like you missed anything, it will be in the recording. 3, 2, 1. Let's move on. All right, so now we're going to go ahead and move on to questions 26 and 28. All right, so we're going to skip 27 for right now and talk about 26 and 28, which are both about mechanical energy. Remember, mechanical energy is the energy of motion and position of objects. Now, that can be broken down even further, where the energy of motion is kinetic energy, right? We talked about the word kinetic means motion, so it's the energy an object has because it's already moving. And potential energy, remember, is the potential to begin moving, right? So remember we talked about how at the higher parts of a roller coaster you have more potential energy because you have more potential to fall, right? At the highest point you can see we actually have 100% potential energy because that's the biggest amount that we could fall from. So potential energy is the energy that an object stores because of where it is positioned, right? So question number 26 asks us about the energy of motion, and question 28 talks about stored energy. So please go ahead and answer both of those. They're super quick ones. I'll give you 45 seconds. Green checks when you have them both saved or you've taken a picture of this slide. All right, waiting on a few more green checks. Alyssa, Amir, Andres, Tony. It's not mechanical, right? Sorry, Dorian. It broke it down into 2 parts, right? There's kinetic, which is for motion, and potential, which is for position. Mechanical is just kind of like the group name, right? It's the category name. But kinetic and potential are actually the 2 choices we're talking about. Okay, let me know if that makes sense. Again, waiting on a few more green checks. Dree, Dylan, Edwin, Jackie, and Misael, Parker, Razi. Looking good. Yep, no worries, Dorian. Mel, I do see you're typing. If you have a question, go ahead, finish up that, and I will get back to it as soon as I see it. Thank you. Let's go ahead and keep on moving. All right, so going back to question number 27, I know we kind of, again, skipped it because it was sandwiched between 2 questions. But question number 27 is asking about the conservation of energy. Right, so conservation of energy says that energy is never created nor destroyed, right? So you can't make new energy, and energy doesn't just magically disappear or it gets deleted from the universe. Instead, it actually just changes from one form to another form, right? So for example, we talked about when a saw cuts a metal pipe, there's electrical energy from the saw that is being used to change it into different types of energy, right? Light energy from the glowing metal, spinning energy, which is mechanical, and flying sparks, which are both heat and friction energy, right? So we're just changing it into different types of energy. It's not actually being destroyed. It's not actually being deleted. All right, so this is question number 27. Give me a green check when you have it saved. 30 seconds. Go, go, go. Sorry, it might be helpful to mention that another word for changed is converted. That should help us with question number 27. Waiting on a few more green checks. Alyssa, Amanda, Amir, Andrea, Andres, Dorian, Dree, Dylan, Edwin, Justin. Thank you, Miguel. Waiting on Misael, Nate, Parker. Green checks, please. Looking good. Again, in every example of energy, energy is never just destroyed, never just deleted. Instead, it gets changed or converted into a different type of energy. Awesome, looking good. All right, here we go. So at this point, we have answered all of the hard questions together. So you should only have a few more questions to answer. And I'm going to go ahead and send you the video that goes over all of those easy questions. Smiley faces if that makes sense. All right, so at this point, we've done all of the hard ones. The easy ones are all that left. And I trust that with the video, you'll do really well on them. Okay? Awesome, yeah. So I'm going to go ahead and send you the link to that. All right, so here's the link to our, sorry, where did I put it? All right, so here is the YouTube link to those easy questions, okay? Now, that being said, if for some reason you don't get the link, or if for some reason someone didn't come to class and they're just watching the recording, I do always include the instruction videos or the extra videos into the recordings as well, right? So if you're watching the 5E recording, just keep on watching it. The same video is still in the 5E recording. So same for any of you in class right now. If for some reason you lose the link, don't worry, it'll be in the 5E recording. Yeah, it always is. I always include it.
Hello students, this is the help video to go ahead and go over the remaining questions in the midterm exam. So remember that what I'm going over right now, these are the easy questions. The hard questions have already been answered in the live class. So either you attended that and you went over those questions with me, or if not, you can watch the recording and the hard questions will be in the recording. Remember, as we go through this, to save your answers so that you do not lose any of your work. All right, so first off, we're going to go ahead and go over questions 1, 3, and 4. Again, we've gone over several questions in class, so go ahead, go back up to the top of your exam, and we are going over 1, 3, and 4. So remember that distance is measured in meters, time is measured in seconds, mass is going to be measured in grams. Remember, the definition of mass is kind of the amount of stuff that an object is made of. Temperature is going to be measured in degrees Celsius. Remember that we don't use degrees Fahrenheit in science because degrees Fahrenheit in science doesn't make a lot of sense, whereas the Celsius scale makes a lot of sense because 0 degrees Celsius is freezing and 100 degrees Celsius is boiling. So that's why we use the Celsius scale in science. So also what I want to talk about are derived units. So remember that derived units means that they are combinations of our fundamental units. So remember over here we have our 4 fundamental units, right? Meters, seconds, grams, and degrees Celsius. Derived units, on the other hand, are combinations of these. So for example, volume is a measure of space, but really it's a combination of distance times distance times distance, right? If you think about how you calculate the volume of a cube, it's length times width times height. So length times width times height would give you volume, right? So since it's a combination of these 3 distances, this is a derived unit. And specifically in this case, we measure volume with liters. So the derived unit would be liters. Excellent. All right, so that's questions 1, 3, and 4. Remember, save your answers for all of those. Moving on to question number 6, again, a lot of these we've already answered, so we're skipping some of them that we went over in class. But moving on to question number 6, remember that graphing is really useful when we get data from a lab because it helps us see the relationship between the independent variable and the dependent variable. Remember, the independent variable is what we change at the start of the experiment, and this is what we are in control of. And this gets plotted on the x-axis, which remember the x-axis is the horizontal axis. The dependent variable, on the other hand, is what you measure at the end of an experiment, again, the result of the experiment, and this actually gets plotted on the y-axis. So the y-axis is right here, this is the vertical one. So for example, if we were looking at a relationship between the temperature of honey and how fast it flows, what we're in control of is temperature. So that's why that's our independent variable, and that is also why it gets graphed on the x-axis, which we can see right here. The flow rate, that's the result or the end of the experiment. That's why it's the dependent variable. And again, this gets graphed on the y-axis. So we can actually see this right here, where flow rate is graphed on the on the y-axis. Apologies. So again, temperature right here, this is our independent variable. Flow rate right here, this is our dependent variable. So make sure you save your answer to number 6. Question number 7 is talking about motion. So remember, motion is just how an object moves from one point to another point. And there were 2 things that we talked about a lot, which is the difference between speed and velocity. Remember, speed is just how fast an object changes position, right? How fast it gets from A to B. And this is measured in distance per time, which could be units like meters per second or miles per hour, right? The meters and the miles are the distances, the seconds and the hours are the times. So distance per time. Now, velocity is actually a combination of this, right? It's actually a combination of speed plus adding in direction. So when we talk about velocity, it's extremely important that we also talk about direction. So for example, you can say that someone's moving 3 meters per second, but to make it a velocity, you have to add that they're moving to the right or that they're moving in the positive directions. Or you could say they're moving to the left or moving in the negative direction, right? We could also say up, down, forwards, backwards, so on and so forth. Now again, velocity is both speed and direction together. And the reason speed does not have positives or negatives is because for speed, direction doesn't matter. So the only thing it matters for is for velocity. Answer number 7 and save your answers. Now, question number 8 is talking about acceleration. Remember, acceleration is defined as any change in velocity over time. And any change means, right, we could be starting motion, we could be getting faster, we could be getting slower, we could be stopping motion, we could even be changing, right? We could actually be changing direction. Because remember, velocity includes direction. So if you change direction, you're changing velocity, and that would also be acceleration. But again, even getting slower, even stopping is still considered acceleration. Even if you're not speeding up, it's still considered acceleration because it is a change in velocity. The way that we calculate it is we take this change in velocity and then we divide it by time, since again, that is in fact the definition of acceleration. All right, so that's question number 8. Save your answer, and then let's keep on going. Question number 13, again, we're skipping a few of these that we went over in class. Question number 13 is talking about Newton's third law of motion. And remember that for every force, there is an opposing force that is in the equal and opposite direction. So when we talk about equal and opposite direction, remember they're parallel, right? So if a force is going to the left, the equal and opposite parallel would be to the right. If a force is going up, the equal and opposite parallel would be down. And if a force is going forwards, an equal and opposite parallel will be going backwards, right? So we can see that these lines are are parallel to each other, right? They're in the same plane, okay? So for example, if you're in a rolling chair and you push forwards, this actually causes the chair to do the equal and opposite force, which is to move backwards, the equal and opposite action. And same thing if you jump off of a boat to the left, the reaction is that the boat actually moves to the right. Again, equal and opposite. So for every action, there's an equal and opposite reaction. All right, so that is question number 13. Make sure you answer that and then save it. Now, again, we're skipping a bunch of these. We are going to quickly go back to question number 9 and then also talk about 15 and 16 because all of these have to do with gravity. So remember that the force of gravity, which we can also call weight, those are actually synonyms. So when you measure your weight, you're actually just measuring the force of gravity on your body. This is the force that an object exerts on another object, and it's based on mass, meaning that the more mass you have, the more gravitational pull you have. So remember, in class we talked a lot about how humans actually have their own gravitational fields. It's just that it's not super attractive because we are very small. Compared to the Earth, for example, the Earth is extremely massive, has lots of mass, and therefore that's why the Earth has such a large gravitational pull, and when you jump, you are attracted back down to the Earth very quickly. Okay, so again, it is based on mass. Now, what's important to note here is that mass and weight are actually different. Remember, mass is just the amount of matter or stuff that you are made of, and this is actually the same no matter where you are in the universe, right? So this is always the same no matter where you are in the universe because you're always made up of the same amount of stuff. You don't suddenly lose the amount of stuff you're made up of as you go from place to place. Weight, on the other hand, is due to gravity on an object. So weight actually includes gravity, which is why, for example, on Earth, where there's more gravity, you actually weigh much more, and that's why, for example, if you jump on Earth, you fall much faster. On the Moon, on the other hand, there's much less gravity, and as a result, your weight, again, this is weight, your weight is much smaller, and that is why when you jump, you fall slower. That's why you see astronauts jumping on the moon, and their jumps are amazing because they have much less gravity and therefore much less weight. Still made up of the same amount of mass, right? You can see this astronaut here is always made up of 100 kilograms of mass, but his weight changes based on gravity. 988 newtons on Earth, 162.2 newtons on the moon. Much different. So again, mass and weight are not the same. The astronaut's mass will be the same everywhere, but the weight can change based on gravity. All right, so that's question number 15 and 16. So make sure that you answer those questions, all 3 of those, and make sure you save your answers. All right. So question number 17, moving on, talks about the universal law of gravitation. So Newton's universal law of gravitation states that 2 objects actually always exert a gravitational force on each other. And this is actually equal and opposite. Remember talking about Newton's third law equal and opposite reactions. So when the Earth pulls on the Moon, keep in mind that the Moon is actually also pulling back on the Earth with the equal and opposite amount of gravity. So we can see this here, the force of gravity pulling on the Moon and the force of gravity pulling on Earth are equal and opposite each other. And this is actually really important because remember that the Moon, because of its gravitational field, is actually causing the tidal waves on Earth. So without it, we wouldn't have tidal waves and our ecosystem would be extremely different. Okay, so that is question number 17. All right, let's keep on moving. Question number 20, again, skipping a few of these that we went over in class. Question number 20 talks about solids, liquids, and gases. So remember that solids, we can see right here, keep their shape, all right, and their molecules have very little thermal or heat energy, and as a result, their molecules can vibrate a little bit, but they're not moving fast enough that they can actually escape their shape. So that's why solids hold their shape. Liquids, on the other hand, their molecules have more thermal energy, so they're able to move more rapidly, right? So they're warmer, they're moving faster, and as a result, they can actually flow past each other. And because they can flow around, they actually take on the bottom of the shape of their container, right? So whatever container you pour a fluid into, that liquid is going to cover the entire bottom of that container and change its shape to match up that container. Gases, on the other hand, remember gases have extremely high amounts of thermal energy, and so they move around very rapidly, and they will continue expanding forever until they reach the end of their container, the edge of their container. All right, so this is question number 20. Make sure you answer that and save your answer. Question number 2 talks about buoyancy. Remember that buoyancy depends on the density of an object versus the density of a fluid. And remember, density is the relationship between mass and volume, right? So an object that has a certain amount of volume, if we have very little mass in it, it has much less density, and so it's very light for the amount of volume it has. If we have that same volume, but we add a ton of mass into it, it's going to be a much bigger density, and it'll be much heavier for its volume. So the difference between a tennis ball and a baseball, for example. Now, again, depending on the density of the fluid, if the density of the object is less than the density of the fluid, then the object will float, and as a result, we actually end up with buoyancy. Remember, the opposite is true. If the density is more, then the object will sink. All right, so that is question number 2. Make sure that you answer that, 22, and save your answer. Okay, so question number 29, skipping a whole bunch of these that we talked about in class. Question number 29 talks about pendulums. So remember that pendulums will swing back and forth between potential and kinetic energy. Remember that at some points, we can actually have both potential and kinetic energy, okay, at the same time. So for example, at the top of our highest point of a pendulum, we can see that we have maximum potential energy because we're at the highest height, but for a moment we stop moving, so we have zero kinetic energy, and you can see the same thing on the other side. At our lowest point right here, what we can see is that we no longer have any height, so our potential energy is zero, but at this point we're actually moving our fastest, which is why our kinetic energy is at its maximum, because remember, kinetic energy is the amount of motion. Right? So this is the amount of motion, potential energy is the amount of height. There we go. Okay, but the really special part here, guys, is that there are points at which we actually have both potential and kinetic energy. Because, for example, you can see here that we do have some height, and we still actually have some, and we also have some motion. So because we have some of both of these, we actually have both potential energy and kinetic energy at points 2 and point 4. All right, so this is question number 29. Make sure you answer that and save your answers. Question number 30 talks about the kinetic theory of matter. The kinetic theory of matter says that it's due to the movement of molecules or their kinetic energy, and this is what actually causes heat. So for example, in hot objects, the molecules have a lot of kinetic energy, meaning they're moving very fast, and so they're making an object feel hot. Cool objects, on the other hand, their molecules are moving very slowly because they don't have a lot of energy, which is why they feel cold. Now, when we talk about this, if we wanted to freeze water, meaning go from hot to cold to freeze something, then obviously we would need to slow down their molecules, right? Because we want to go to a cool object, we want to remove that energy and slow it down. The opposite is true then, that if we want to go from cold to hot, we would actually need to speed those molecules up, right? So for example, if we melt ice, we want to speed the molecules up to get them faster, to get them hotter. That's question number 30. Make sure you save your answer. Question number 31 talks about thermal equilibrium and conduction. So remember that we talked about when heat moves, it can only move from hot to cold, because remember, cold is just the absence of heat, and so nothing can move from cold to hot because cold isn't a real thing. So it has to go from hot to cold, and as it does this, it will go from hot to cold until both objects have the same temperature, which is called thermal equilibrium, right? We can see this here, hot to cold, it equals out at a certain medium temperature. Now, this being said, this idea of moving from hot to cold when objects are touching, this is what's called conduction. So the movement of heat when objects are touching is due to the molecules colliding. So for example, as the molecules with the coffee collide with the spoon will get hotter and hotter. Or for example, as the molecules from the tip of this needle, which is very hot, collide with the cool part, that will get hotter and hotter and eventually also reach your hands, and through conduction make your hand hotter. That's question number 31. Make sure you save your answers. Last but not least, this is 2 slides, so make sure you watch the next slide as well. When we talk about the way that heat moves, there are 3 ways that it moves. The first way is convection. So remember, the first way is conduction. The second way is convection, right? This is our second way. Convection means that when fluids are heated, like air or water, they become less dense, and as a result, they're going to rise. On the other hand, when fluids get cooled, like water or air, they're actually going to do the opposite. They get more dense, and so they sink. And as this rising and sinking happens, we can see this right here, this creates what are called convection currents, which stirs around the fluid, spreading out that heat. Again, we're talking about ways that heat moves. And again, this can happen to both fluids like gases like air and liquids like water. Fluids include both gases and liquids. Don't answer question number 2 yet, 32 yet. We still need to go on to the next part. The third way that heat can move is through radiation. So remember, radiation is a special one that does not need matter to travel. So we saw here, right, conduction requires objects to be touching, which means it requires molecules, and convection requires fluids, which means it requires molecules. Radiation, on the other hand, does not. It requires no molecules, no matter. Instead, it's able to transfer energy through these special waves called electromagnetic waves, which is really important because, for example, sun is able to reach us, sunlight can reach us through empty space, right? There is no matter in empty space, and yet the sunlight can still move through it. So that's really important because otherwise we would not get sunlight and we would all die. So radiation, for example, could also be from fire. Fire is able to heat objects without using these other methods that require matter. All right, so at this point you should now be able to answer question number 32. Make sure you do that. And that's all for your questions. Thanks so much, guys, and I'll see you later.
Cool. All right, everyone. So I'm going to go ahead and send you your attendance ticket with the password now, since I did tell you I was going to save the password till the end, save the attendance ticket till the end. So there's the attendance ticket. The password's right underneath it. All right, so go ahead and get that, and then here is your last word. If you need to, just take a picture of the password and the last word, and then you're good to log off. Thanks so much, everyone. Have a wonderful day. Don't forget the password, all right? Make sure you get that password. See you all later. Have a great day.